The universe began with the Big Bang, a massive explosion of energy and matter that marked the birth of everything we know. This colossal event occurred approximately 13.8 billion years ago, setting into motion the expansion of the universe. In its earliest moments, the universe was unimaginably hot and dense, a seething cauldron of subatomic particles like quarks and gluons. As it expanded and cooled, these particles combined to form protons and neutrons, the building blocks of atomic nuclei. Within the first few minutes, the universe had cooled enough for these protons and neutrons to come together and form the simplest elements, hydrogen and helium. This period is known as Big Bang nucleosynthesis. These primordial elements were crucial, as they later became the raw materials for the formation of stars and galaxies. As the universe continued to expand and cool over the next few 100,000 years, electrons began to combine with these nuclei to form neutral atoms. This era, known as recombination, allowed light to travel freely through space for the first time, creating what we now observe as the cosmic microwave background radiation, a faint glow that fills the universe and provides a snapshot of the infant cosmos. Over billions of years, gravity pulled together clouds of hydrogen and helium, igniting nuclear fusion in the cores of the first stars. These stars lived out their lives, producing heavier elements in their cores, and eventually exploding as supernovae, scattering these elements across space. This cosmic recycling process led to the formation of new stars, planets, and eventually, the complex structures we see in the universe today. The Big Bang theory is supported by a wealth of observational evidence, including the expansion of the universe, the abundance of light elements, and the cosmic microwave background radiation. It remains one of the most profound and well-supported theories in modern cosmology, offering a glimpse into the origins and evolution of the cosmos. Over millions of years, gravity pulled hydrogen and helium together, forming the first stars. These stars grouped into small proto-galaxies, which would later merge to form larger galaxies. Smaller proto-galaxies collided due to gravitational attraction. These violent mergers resulted in the formation of a larger structure, which would eventually become the Milky Way. Over time, the new galaxy took on a rotating disk shape, with spiral arms forming as stars and gas clouds followed gravitational patterns. The central bulge of the galaxy also grew as more matter accumulated. The formation of a spiral galaxy is a fascinating process that spans millions of years. Initially, the galaxy starts as a chaotic collection of stars, gas, and dust. Through the influence of gravity, these components begin to coalesce and form a more organized structure. The rotation of the galaxy plays a crucial role in this transformation. As the galaxy spins, centrifugal forces cause the material to flatten into a disk. This disk is not uniform, it has regions of varying density. The spiral arms are one of the most striking features of these galaxies. They are not solid structures but rather areas of higher density within the disk. Stars and gas clouds move in and out of these arms, creating a dynamic and ever-changing pattern. The arms are often sites of active star formation, where new stars are born from the dense clouds of gas and dust. This ongoing process adds to the brightness and complexity of the spiral structure. At the center of the galaxy lies the bulge, a densely packed region of stars. This central bulge grows over time as more matter is pulled in by the galaxy's gravitational pull. The bulge is often home to older stars and can contain a supermassive black hole at its core. The interplay between the bulge, the disk, and the spiral arms creates the beautiful and intricate structure that we observe in spiral galaxies today. Understanding the formation of spiral galaxies helps astronomers learn more about the evolution of the universe and the forces that shape it. Each galaxy tells a unique story of creation, transformation, and growth, offering a glimpse into the vast and dynamic cosmos. The Milky Way continued to grow by absorbing smaller galaxies and forming new stars. The spiral arms became well-defined, and the galaxy's structure stabilized. About 4.6 billion years ago, within one of the Milky Way's spiral arms, a massive cloud of gas and dust began to collapse under its own gravity. This immense cloud, known as a solar nebula, was composed of hydrogen, helium, and traces of heavier elements. As it collapsed, it started to spin faster and flatten into a disk. At the center of this disk, material clumped together to form a protostar, which would eventually ignite to become our sun. Surrounding this young star, the remaining gas and dust began to coalesce into smaller clumps. These clumps collided and stuck together, gradually growing into planetesimals, the building blocks of planets. Over millions of years, these planetesimals continued to collide and merge, forming the planets, moons, asteroids, and comets that make up our solar system today. The inner part of the disk, where temperatures were higher, gave rise to the rocky planets like Mercury, Venus, Earth, and Mars. Further out, where it was cooler, gas giants like Jupiter and Saturn, and ice giants like Uranus and Neptune took shape. This process of formation was chaotic and violent, with frequent collisions and rearrangements. Yet, out of this cosmic turmoil, a stable system emerged with the sun at its center, surrounded by a diverse array of celestial bodies, each with its own unique characteristics and history. This event, the birth of our solar system, set the stage for the development of life on Earth and the exploration of the cosmos by humanity. It is a story of transformation, from a cloud of gas and dust to a complex and dynamic system that continues to evolve to this day. At the heart of the Milky Way lies Sagittarius A*, a supermassive black hole that has influenced the galaxy's structure and motion. It has a mass of about 4 million suns. Today, the Milky Way contains around 200 to 400 billion stars, countless planets, and vast clouds of gas and dust. It stretches about 100,000 light-years across and continues to evolve. The Milky Way and the Andromeda Galaxy are on a collision course. In about 4.5 billion years, they will merge to form a new, larger galaxy. Even after merging with Andromeda, the Milky Way's stars, planets, and remnants will continue their cosmic journey, playing a role in the vast, ever